From the Microsoft Technology Center in Minneapolis, Minnesota, this is Tech Connection Live, brought to you by Component One Ultimate. Download your free trial at componentone.com/ultimate. Up next, Practical MVVM by Joel Cochran, Expression Blend MVP and Senior Technology Consultant at Lodic Factor.
So let me start with a couple polls. The first is, who is already doing XAML development of any flavor? WPF, Silverlight, Phone. Okay, a few people. WinForms? A few people. I'll guess the rest of you are probably web stack, a lot of maybe some JavaScript, MVC, that kind of stuff. Okay. Anybody have no idea about any of those things? Okay. I'm not going to put you on the spot, but what are you doing?
I'm a WordPress developer.
WordPress. Okay. Well, I hope you enjoyed my talk.
I know JavaScript. I know jQuery.
Oh, okay. Okay. No, great. This is fantastic. So my talk is XAML oriented. I have a lot more experience in the XAML space in the last few years than anything else, but the things that I'm going to talk about do have, the concepts I'm going to talk about, do have practical application in JavaScript and in Windows 8 going forward, both in the JavaScript and the XAML stack. And so if you have any questions about that as we go ahead, feel free to bring up Windows 8. We can talk about that as well. The stuff that I'm going to be showing today, though, is all Visual Studio 2010, Windows 8, and Expression Blend 4 oriented. So you should be able to go back to work and use this stuff pretty quickly, right? So we're not talking future. This is stuff I've been doing for the last several years, and I'm going to give you my take on it, which is different than a lot of other people's. Just real quick, I am a senior technology consultant with a small company called Lodic Factor out of Roanoke, Virginia. We're a full-charge business and technology consultant with a focus on cloud and mobile integration. I'm Expression Blend MVP. You won't find a whole lot of us floating around. There's 5 of us in the US. But that does mean that my particular passion, my evangelism, if you will, in the community is centered around Expression Blend, which is going to play a large part in what we're going to talk about today. MCTS, some other letters and stuff, WinForms and WPF, that just shows I've been doing desktop development for quite a while. And then if you ever do have any questions about any of this kind of stuff, or bacon, I love to talk about bacon too, you can mail me at joelcochran@gmail.com or find me on Twitter at Joel Cochran. So enough about me. I do want to thank Component One for bringing me out here to talk to you guys, and I'm happy to be associated with them. It's a great organization, and obviously you guys are already aware of that, but I did want to say thank you for having me. Real quick, well, I will keep talking about me, my favorite topic. Expression Blend in Action is a book that I've written for Manning Publications. If you are interested in specifically the developing in the XAML space, again, really of any flavor, this is a book about Expression Blend from the developer's perspective. So Blend is misquoted as a design tool, or designer's tool, and that's incorrect. Expression Blend is a developer's tool for the design task. How many developers in here never ever have to do any design work ever? You're very lucky. You're the only one, by the way, in here who raised your hand. And all the rest of us, we get stuck doing design work, don't we? The smaller your shop is, the more design work you get to do. So Expression Blend is a fantastic tool for doing design work, but it's really geared towards developers. Microsoft won't agree with me, but that's okay, they're wrong. So I did write this book. If you're really interested, I recommend that you get it. If you use this discount code, you can get 40% off with my compliments. And if you're interested, I'll show that later. I don't want to spend any time on it now. It is an electronic book, so there won't be any print version of that particular volume. All right, so let's talk about MVVM. Those of you already doing XAML-oriented development, who's comfortable with MVVM or thinks they are? Okay. Anyone, MVC, comfortable with MVC? Of any flavor, not necessarily ASP.NET, just the concepts. All right. MVVM is a flavor of what I call the MV star pattern. And it's this concept of separation of concerns across the layers of your application. Some are UI layers. That's the view, the V in MV. And some are the model layer. That's the representation of your data. And then we have this other thing, and that's the star. So the MVC pattern is the model view controller. So if you're doing ASP.NET MVC development, the cycle looks and feels something like this. User goes to a web page and they make a request. Request goes back to the server and gets processed by the controller. Controller analyzes the request, decides what to do with it, maybe goes and captures some model data, builds up a model class, or maybe even a view model class, depending on how up-to-date your MVC approach is. And then it bundles that up and it passes that data off to the view. The view's job then is to restructure and display that data, present the user interface to the user. Are we okay so far? Are we okay so far? Are we awake? I don't know. Okay, so that's great. That's fine, and that's a very well-proven pattern. What happens then when the user pushes a button on the view? Everything I just said. It has to go all the way back to the server. It has to route through the routing engine. It has to find the correct controller. May or may not be the same controller that it just came from. It has to locate the view that it's going to, which may or may not be the same view that it just came from. It has to analyze the data, has to validate, capture a new model, bundle up some information, and push it off to some other view that may or may not be the one it just came from. Does that sound right?
Yes.
No? Who said no? Okay, you're wrong. Whoever said it, you're wrong. Yes, okay, so that's MVC. MVC is a loop. Now, not to show my age or anything, but I actually came out of AS400 RPG development. And if you don't know what that is a structured procedural language. And it has this thing in it called the cycle. And the cycle does exactly this. It starts at the top of the program, and it goes to the bottom of the program. And then it says, well, I'm going to go back to the top and see if I have to do anything else again. And you're constantly looping through this cycle. Everything goes in one direction. That's kind of how I see MVC. Where MVVM differs is that you have two-way communication between the view and the view model. So it allows us to do things like data binding in a really effective way and pass information without constantly going back through this loop and constantly recycling. So that's sort of at the core of what we're going to talk about today. Two-way communications, true separation of concerns, supports data binding. And the reason that this is so important to me is my all-time favorite feature of Expression Blend, I can't talk without talking about Blend, is data binding. If there's only one reason for you as a developer to adopt XAML technologies, it's data binding. And once you become a XAML developer or in the process, the number one reason that you should be using Expression Blend is data binding. Data binding is a facility for the view to bind or connect to the data properties in the classes behind it, which you might think of as a controller, but we're going to call a view model. And that communication, again, is two-way. So without constantly rebuilding the view, I can push information in and out of my view automatically through this facility called data binding. And Expression Blend makes setting up data binding really easy. So the last thing about MVVM is it allows us to have no code behind, almost. Anyway, code behind? Everyone who's used code behind, put your hand up. If you've done ASP.NET, if you've done WinForms, you've done code behind. Okay? It's that little extra file, that CS or VB file that gets created that's kind of hanging off of your view, and you put your event handlers in there and stuff like that. That's your code behind. Code behind is architecturally ugly because it's difficult, if not impossible, to test. It binds the actions, the things that are going on in your view, it binds them to the view itself rather than separating those concerns. So it forces us to do a lot of things in code behind rather than having nice like I said, a nice separation of concerns in our architecture. So we like to avoid code behind, and through the miracle of data binding in MVVM, in XAML applications, we can do that. So that's what we're going to be looking at today. So some of the problems that I see with people's perception of MVVM is they don't necessarily use the right terminology and what all these moving parts are. So let's do a real quick run through what the different things mean. The model layer, model classes, your data. The misconception that happens here is that people think of the database as the model. Right? Well, that doesn't make any sense because it's the database. It's the model that's the model. Sometimes. Entity framework users, any entity framework users, or a link to SQL, or some other ORM. Okay? If you're not using one out of the box, you wrote it to do it yourself, I promise. You're using something, some class, that represents the structure of your database, hopefully controls validation and authentication and all that kind of great stuff. But it allows you, it's the code that you use to talk to your database. Those are model classes. Now, they can come from data services. They can come from XML files. It can be entity framework. All that, you know, it doesn't matter where this data comes from. We're just talking about the classes that model our data. Those classes, those instances, are consumed by our view models. So the view model holds on to that object for us. There are varying ways that you can abstract that away. One of the very popular ones is to specifically not use entity framework classes or other ORM classes. These are very heavyweight objects with a lot of features that we don't downstream, we don't want actually in our view itself. So one of the very popular things to do is to take an entity framework or an ORM model and wrap it extract that data into a DTO, just a dumb data transfer object, and use those objects as our models. That's more popular in MVC land than in WPF, but it's certainly viable. A model is unaware of the view that's going to present it, and it's unaware of the view model that's going to consume it. It's just a dumb object. Questions?
Yeah.
Okay.
So the model isn't. Is it the data itself, or is it the structure?
It's really the structure. It's going to hold the data, but it's really the structure that represents the data. So it's the class that defines all the properties that your model holds. And then at runtime, it's going to hold data. It's the data, it's going to transport data. It's going to hold the data. But conceptually, the model itself is just the description of the data.
Okay.
It's at that point, it's a little semantic, but it does matter because we don't want the model to be directly tied to the database, and we'll see why in a little bit. So the view then, this is a little bit more than the screen, but it's essentially the user experience. It's the UX and the UI. It's everything that the user sees. It's the visual representation of the data. And in this case, we're talking WPF, Silverlight, or Windows Phone 7, but down the road, like I said, we can do this stuff in JavaScript now with tools like Knockout. In Windows 8, this is baked in with WinJS if you're doing the JavaScript side of Metro, and you can continue to do this stuff in the XAML side of Metro. So MVVM is here to stay, and it's growing across multiple platforms now. The view is populated by the view model. So the view model that really is kind of controlling everything, the part that we'll talk about next, is also being used to manage what gets displayed on the view. So just to tie back into our discussion about models a little bit, you may have many models in a single view model. If you're you have a page that's that's aggregating several different things in a dashboard or something, you may have several different model collections or model classes represented within that single view model. And then that single view model is going to get passed off to the view itself. The view is technically unaware of the view model. And I will demonstrate this when we get to the actual data binding. Just for now, I want you to see that phrase, unaware. And then finally, we have the real focus of our effort as developers, and that's the view model. The view model is the master and commander. This is the guy that sits in the middle of our entire application and basically manages everything. It's responsible for communications to the back end, so calling into a service layer or something like that to extract those model pieces. It's responsible for data formatting. It's responsible for responding to user input, even though that happens on the view. Data binding sends that interaction back to the view model to do stuff. The view model, really, in my mind, that's the program. It's the view model that's really doing everything. And here's that word unaware again. The view model is unaware of the view. So even though it's in charge, it doesn't reference the view directly. So if we remember back to model, we said the model was unaware of the view model and the view. We said the view is unaware of the view model. And now we say the view model is unaware of the view. There's an awful lot of unawareness or ignorance going on. This is a really ignorant system. Who would implement this, right? I call this connected ignorance. These things aren't really aware of each other, but they work together. They are connected, but they aren't aware. Okay, so here's a little diagram I put together that outlines the different layers. And I put them in the order that they actually physically make sense. So if you said it this way, it'd be the model, view pattern. And really, model was originally called data model, so it'd be DMVMV. So that'd be a lot of fun to say at parties and presentations. But anyway, so our top layer is the model layer. Data source is our actual database or XML files or whatever that happens to be. Our modeled entities then is the code that knows how to talk to that database for us and formats our data. And we have this kind of nebulous thing called the data access service. And don't confuse that with like WCF services or something like that. It's whatever your chosen mechanism is for communicating with these model entities, for pulling them out, for pushing data back to your data layer. Okay, there's this concept of a service, and we're going to see that in the code. And then in the middle here is this thing called the view model. And the view model connects to the view. The view has a code behind file, so even though we're going to try not to use it, it does still physically exist. And what makes this communication possible is this layer here called data binding. That's where all the magic really happens. So this is the broad view of the structure of MVVM as I see it. So in doing MVVM for several years, I've had a lot of opportunities to help other people kind of come to grips with it, because the experience that I've had is a lot of really smart people that I look up to and admire, struggle with this. Because when you read about MVVM, it sounds horribly complex. And nobody can seem to agree on those moving parts that we just talked about. And I do want to reiterate that what I'm telling you today, this is my take on MVVM. If you don't agree with me, I'm totally okay with that. There's more than one way to skin a cat. However, this is my cat, and we're going to skin it my way. All right? So in trying to teach other people, I came up with this thing called the Practical MVVM Manifesto. And when I told a friend about it, he said, oh, great, another manifesto. Yeah, sorry. I was being clever. What could I say? And if you are interested, somewhere out here on the interwebs, there is a website devoted to this. It's a whole whopping 2 pages. Oh, no, it's up to 3 pages. There's the manifesto page itself, which we're going to talk about. And then there's also a link here that will take you to the presentation artifacts, which is the demo that we're going to walk through today. There we go. So feel free to download these from this website and go through them in the slides that we just walked through are out there as well. So what I came up with are 4 basic principles that if you are implementing MVVM, you should satisfy these guidelines. I don't care if you do it exactly my way or not, except for, well, yeah, no, I do care. Like I said, there are things that don't necessarily take these into play, but if I were evaluating another MVVM framework, of which there are many, I would evaluate it based on these criteria. So the first is the simplicity principle. The most common mistake that I see people make with MVVM is they over-architect. They make it too complex. So remember I said that we're going to wrap up all these different models into a single view model and hand that view model object off to our view? That's essentially what the simplicity principle says. It says that every view should have a single view model, and every view model should service a single view. The idea there is I always know which pieces go together, and I don't get hung up on terminology. Because you will see people say, well, I have a screen, and I've got 3 list boxes, and I have a view model for each list box. Well, that's wrong, because the list box is not the view. The UX is the view. The screen is the view. Those 3 list boxes should be represented by properties collections within your view, but each one should not have a view model itself. So the simplicity principle says 1 view model, 1 view, and we use a naming convention to hook them together. So that we always know when we open this project 2 years later and I haven't worked on it, but I wrote it, so I'm the one who's got to maintain it. I always know what's going on, and I know which pieces to go work on. Keep it simple. We'll walk through the code and see these one at a time as we go. And what we have here is the base structure that I start all of my XAML applications with. The default window that gets created is called mainwindow.xaml. So I've created a folder here for my models, and I've created a folder for my view models. If you want to go the step farther and create a separate folder for your views, that's fine. By default, they get put in the root, and I just tend to leave them there. That's fine if you want to add another layer there for your views. But within my view models, I create a view model class that has the same naming convention as the view that it represents. So main window is always named main window view model. Clear as mud? All right. Before we get into what's in main window view model, let's look at a view model base. So this is an abstract class that we're going to use. And it does one really important job for us. It implements this interface called iNotifyPropertyChange. It comes out of system.componentModel. And iNotifyPropertyChange provides for us a single event that sends out, broadcasts a message about when a property has been updated. Now, this is the key to that data binding thing that we mentioned earlier. This is what makes data binding happen. When something is bound to a property and that property gets reported as changed, it's an instruction to the data binding engine to reevaluate the data and see if it needs to be updated. And that can go again in both directions. So in order to create a view model, all you really have to do is implement iNotifyPropertyChanged. So I've added a little helper code in here. And this part is very common. You'll see this in almost every MVVM implementation of every flavor. I've added a little helper method that will raise property changed. Okay, so that's our abstract base class. Let's go look at the actual implementation. Here's my main window view model. Inheriting from view model base. And I've gone ahead and added two properties in here. One is a simple string property. And you'll notice that A, it's a fully backed property, not an automatic property. And the reason for that is B, in the setter, every time we're setting it, we're raising that property changed. So now I can bind to this property in my view, and it will automatically push the data around. When I said no code behind before, just to be clear, what I really mean is you will never ever see me write code that says textbox1.text equals value, or value equals textbox1.text. I am no longer interfacing directly with the controls. I'm letting the binding system handle it. And this works in third-party controls just as easily as it does in Windows controls. It's part of XAML itself. The other property that I have here is a special collection type. That special collection type is an observable collection. Again, comes out of system.component model. It's part of the framework. And what it does is it provides for us on collection changed notification. So when the contents of this observable collection changed, the binding system is automatically notified. So notice I'm not raising on collection changed or anything like that. I am, however, still raising property changed. Anyone want to hazard a guess as to why? What it really is that notify collection changed thingy only works inside it only works inside this property. So when I replace this property with a new reference to a new collection, that doesn't get any kind of notification. So I have to raise property changed on the collection property itself so that I can replace it at will, and the binding system will still pick up the new collection in lieu of the old collection. Does that make sense? It's for the reference to the collection itself. The notify collection change works within the collection. This is to the reference to the collection itself. And that's something that we're going to use quite a bit when we're updating our data collections. And you'll notice that that's all that's in here. I've got a couple properties, and I'm making sure that I raise this property notify changed event. Second principle, the blendability principle. Like I said earlier, Blend is a fantastic tool for data binding. What really makes it so good is that it has the innate ability to attach to, discover your view models, and using reflection, show you the properties so that within the tooling, the binding is just there. All the properties are there. In certain implementations of MVVM, you can do some things that will prevent that from happening. So the intent of the blendability principle is to not interfere with the innate abilities of the tools. Your architecture should support the first-class tooling. So the good news is this is really easy to do. And I do something a little different with this presentation. We're actually using source control so that you don't have to watch me code. So we're going to update to the next version. And we'll go to Visual Studio, say yes to all, and we will build. The only addition in our view model is this guy right here, a public parameterless constructor. Now, C# gurus in the room, I know what you want to say. This is already there, isn't it? Even if you can't see it, this is there out of the box. I like to hard code it, and then also later we're going to expand on it. So we're going to go ahead and put it in there. So if this looks like it doesn't do anything, technically you're right, but visually it tells me, okay, I'm satisfying my requirement for a public parameterless constructor. Anybody have a problem with a public parameterless constructor? There's always at least one. Go ahead. What's your problem? I'm sorry. What's your concern?
How might you inject external dependencies?
Fantastic question. The answer is you don't have to use this constructor. It just has to be there. So you can still add another constructor that does that. And matter of fact, we're going to do that later on. Okay? But what happens, and I'm really glad you brought this up, what happens when people like to do dependency injection and they create a constructor that takes a dependency and they're using DI or one of those great tools or something to fill that in, and that's fantastic, is they then like to go and do this. That's the norm. Right? If I'm saying that there needs to be a dependency here at runtime, I'm protecting myself from making a mistake. And I totally get that. Here's the problem. Let's jump over to Blend now. Oh, actually, well, okay, I'll say yes. I need to go and compile that since I made that change. All right, now we'll switch back to Blend. I want to add a data source. And I already have one here, so I'm just going to blow that away, and I'll show you how you can do this. So we'll delete data source, yes. All right, so this is from Fresh. And you'll see I've just added a little bit of UI. We've got a place for that collection to bind to here in a little bit, and we've got a place up at the top for that string to bind to. So those two properties that we created, we're going to be using those, and that's where they're going to go. But for right now, I don't have anything. So I want to connect to that view model that I created. I'm going to go to Create Data Source, Create Object Data Source. And Blend is searching all of its references for classes that it could use, that I can bind to. Because I can really bind to just about any class. So I'm not going to go through all of the ones in the list. But if we look in Manifesto Implementation, I don't have that view model anywhere in here. I can't see it because reflection can only find, in this case, and I'll explain why momentarily, can only find classes with public parameterless constructors. So by doing that very good architecture decision, I have now screwed up my first class tooling. And that's exactly where it happens, which is why it was important enough to make a principle out of. So we want to make sure that we leave in place the things that have to be there for us to be able to do this. So let's make this public again. We'll build. We'll shoot back over to Blend. And we'll go back to its object data source, manifesto implementation, and now my view models show up, and there is my main window view model. So we couldn't see it before because of a very good decision. Unfortunately, we kind of have to be willing to eat that particular problem. Okay? So now I can accept this. Let me zoom out of this real quick, and I'll say OK. And look on the left what happens. We now have this beautiful reflected image of our view model. And it looks a little more complicated because it unnested that, that collection for us. These are really the two properties that we were looking at. There's our collection property and there's our string property. So these are the two things that we're going to be working with. Let's look at the XAML real quick. So let me pull up the XAML. Matter of fact, I'll share with you guys one of my favorites. Well, let's build this. By the way, anytime that you're using Blend and Visual Studio like this simultaneously on the same project, there are no specific Blend files. Blend doesn't add anything to the structure or solution. However, because you're working on the same files in two tools, you have to make sure that you're saving when you're switching between them so that you don't lose work. So my habit is to build anytime that I'm moving from one to the other. That way if I broke it, I'm in the tool that I broke it in, because that's probably where I'm going to need to fix it. Does that make sense? So that's why I'm doing a bunch of building. So we'll do a quick build, and it's the same keystrokes in Blend that it is in Visual Studio. So very comfortable for a Visual Studio user. And now I'm going to jump back over to Visual Studio. And the reason that we're doing this is we're going to edit XAML. Now, Blend is actually a XAML editor. Visual Studio is a text editor. XAML is what?
Text.
Right. So I don't edit XAML in Blend. I edit XAML in Visual Studio because that's text. I edit UI in Blend because that's visual. Make sense? So that's why we jumped over to Visual Studio to do this. So let's open this up. And what I want you to see is what got created when we found that class and made it a data source. So I'm going to zoom in just a little bit here. And here's the first thing. Let me reformat. There you go. Manifesto implementation underscore view models. This line right here. This is how you declare a namespace in XAML. So this is essentially a using statement. So I'm referencing the manifesto implementation view model namespace. And within it, you'll see there's the reference to CLR namespace. I'm sorry, this is the reference. This is technically the name. So in my code, I'm going to use a name, a prefix of manifesto implementation underscore view models. The CLR namespace line is the actual declaration or reference using statement. So now that I have that, if I look in my resources, you'll see that here we are actually using that reference. And this is how you instantiate objects in XAML. So you can actually and frequently will instantiate objects directly in markup. So a couple of things that you have to be willing to do in order for this whole tooling blendability principle to succeed. The first is you have to be willing to leave the parameterless constructor public, regardless of the rest of your implementation. This is the second. There are a lot of people who dislike declaring objects in markup. I understand that. However, I like the tools a heck of a lot more than being that pure. So, fine. I'm going to go ahead and declare my view model in XAML. This is really important because it's what allows us to, later on, have design time data, which is the next principle that we're going to talk about. Any questions? Yes?
Yeah, where'd you get the data template?
Oh, so this code has been worked on. That's something that I wrote. Oh. We could delete it and put it back. It's not overly apropos to what we're talking about, but I'll show it to you when it comes up. Okay. So yes, so we need to have this reference because what happens in Blend? Let's go back over to Blend now. Blend, remember I said that that's how you instantiate objects in XAML? Not declare, not define, instantiate. Blend, at design time, is instantiating an instance of that view model class. Does that make sense? So Blend, even though we're not running the application, has an actual instance of this view model class. And that's what allows that reflection, that discovery over here. This is proactive. If we go make any changes to our view model, they'll immediately and automatically show up over here. And it's what also provides us the ability in the next step to do design time data. I'll do a couple more things real quick on data binding because, again, this is really the key. If you take nothing else away today, take away how awesome Blend is with data binding. We've now instantiated this object, but we're not using it anywhere. So we need to create a data context is what it's called in our XAML code that now that we have this instance of viewModel that tells parts or all of our application that it can use that to go and find data for binding. It's a hook. We have to hook these two things together. So really simply, in Blend, I'm going to grab that viewModel. I'm just going to grab it, and I'm going to drag it. And normally I do this before I put any UI on here. So I'm going to skip dropping it on the artboard, and we're going to go all the way over to the lower left-hand corner. And we're going to drop it on the root grid. I'm still holding the mouse key down, so real quick, notice that it tells us what it wants to do. It wants to data bind this grid, which is our layout root for the entire application. It wants to bind its data context property to that instance of the viewModel that we created. When I do this and I let go, because we dropped it on our root layout container, everything that we put in this UI now has access to all of those properties in the viewModel. One viewModel, one view. Make sense? So let's look at the XAML and see what happened. I'll build this real quick. This is part of that keeping files in sync. I changed this XAML file over in Blend, and now I'm trying to open it in Visual Studio, so it's prompting me. The answer is always yes to all. So I'll say yes to all. And now, we'll do Control-KD to reformat. OK, so this part hasn't changed because that was still declared. Let's go down and find our grid. Here's our grid. Here's our data context property that we just dropped that main window viewModel data source. We're binding those two things together. And if we go back up and look, that was the name, or technically the key because it's a resource, not a name. That's the name of this instance of our main window viewModel. So that's how they're connected to one another. Fuzzy? It's actually pretty straightforward, right? I got this one thing here. I got this container over here. Make them talk to each other. Yep.
Why didn't you do it on the window?
Habit. No particular reason. I don't like to muck up the Windows XAML because it gets pretty ugly with all the namespaces and stuff anyway. You can put a data context anywhere. So while I do say one viewModel, one view, that rule does not extend to data context. Data contexts get used all over the place. So a real simple example is a list and detail view. The detail area may be a grid that it represents the selected item in the list. When you select that item in the list, you can bind the data context of that grid for those details to the selected item in the list. So that's a different data context. It has nothing to do with the viewModel. It's just how I'm going to reference bindings in XAML. Now that probably did fuzzy things up a bit, but I just want to make it clear. Data context, feel free to use as often as you need. As long as you still only have one viewModel instance in your class, you're good in my book. OK, so let's look at designability. The designability principle says that as long as I have these first-class tools, let's take advantage of them. Blend, being a design time tool, should therefore have the capability to display design time data. So in other words, my architecture should provide at least the capacity for design time data. And this actually becomes a really simple thing to do as long as we're following these other processes, these other principles, using MVVM and data binding. So let's jump over to design time data. We'll go back to Visual Studio. Have to reload. OK. now things are starting to get a little more architecturally interesting. Remember back on our beautiful fancy diagram that had all the boxes and balloons and stuff on it, that I had that nebulous thing up in the upper right-hand corner called a service. So what we're going to do is institute in our code the concept of a service layer. Again, not to be confused with web services or WCF services or a specific kind of service, just a concept. You may think of these as a repository also, kind of along the same lines. So our service layer, if I open this up, and you'll notice I've added a folder for services. This very well could be in a different project. Okay, this is obviously a demo type application. Feel free to abstract these things and move them around as much as you need to. But inside my service, I've created an interface for my real estate data. And I'm just abstracting away the concept of get real estate masters, or get all real estate masters, and get real estate by owner's name. This is a real estate database that we're playing with, obviously. And we have that property for search name that we haven't done much with yet. So we're going to be passing that into the service layer to get back a specific item. Okay, or a matching set of items. So let's go then and look at an actual implementation. And there is a live SQL server running on this machine. And here is the actual implementation. So you can see that we have a EF context, real estate data service. There's our get real estate masters, just gets all of them. And real estate by owner, is doing some actual EF link code to extract the ones that match. So this is live database code. I don't want to plug this in to my view model directly. Because if I do, Blend, which instantiates that view model, will then be actually designing against the live data in my database. Bad idea. I'll tell you that from experience. Bad idea. So we had to find a way to break these things apart, and that's where the interface comes into play. So if we go then and look in our Solution Explorer at Real Estate Data Service mock, you'll see that we're just returning some faked up data. So now what I need is the ability at design time to hook into this data, into this instance of that service, but at runtime, hook into the real deal. Okay, so now let's go back and look at our view model. And we'll actually start by pulling up our view model base, because we've added one more property. And we put it in our abstract base because we're going to use it in all of our view models. And this gives us the ability to determine whether or not we are in design mode or actually executing at runtime. And Laurent Bouznan, one of the framework authors, MVVM Lite is the MVVM framework he wrote. He wrote this. I borrowed it from him. So I can't take credit for the code, but I will take credit for using it. All right, so is in design mode as part of our view model then lets us, by abstracting our service as a property in our view model, if I'm in design mode, new up real estate data service mock. If I'm not in design mode, then go get me the real deal. You probably want to ask a question about dependency injection and why I don't have DI in here, right? I will tell you why I don't have DI in here. DI does not solve the problem of design time. Because the app never starts up, the IOC container never gets constructed, and it'll just return null. Works great at runtime. So actually in production, my code, this part is wrapped in DI, but the design time piece isn't. That's my production code looks like that. Okay, but great question. Thanks for asking. So we have both of these serviced. Now, the rest of this is just some fairly standard cruft around it. We're only going to new it up once. If we go back to our constructor, we're now calling, I said we were going to add something to it. So our empty constructor calls start app. So blend instantiates this, which calls start app. Start app then goes through a startup procedure. And this looks like it's unnecessary because I'm only calling one method. In production, you're likely to have multiple method calls in here to load multiple kinds of data. So now we're going to call load real estate collection. Load real estate collection says go to my service property, which we've already seen will either be mock or real. So at design time, this will be fake, and everything else just works. So you don't have to, and plenty of times you will see people try to do this, and then what they do is create mock view models, where everything in the view model is mocked out and faked. You don't actually have to do that. And if I'm going to be testing a view model, I want to actually exercise the real view model. So I'm now exercising the real view model just with mock data. Make sense? It's a very clean, in my opinion, a very clean way of doing this. And my service goes out and brings back a query, which I then turn into an observable collection. OK. And the rest of this, we'll get back to that in a minute. These binding properties are the ones that we've saw before. They haven't changed. And we'll look at that load real estate collection by name shortly. So now that we are actually getting data to play with, let's build this. And we'll swap back over to Blend. And we'll say yes. And lo and behold, that is design time data. Those are those two entries that we put in that mock collection. This also, I've been talking about Blend a lot because I don't do design work, just like I don't do text editing in Blend. I don't do design work in Visual Studio. However, if we go ahead and pull up our main window XAML and go to the design surface, it works in Visual Studio as well. The architecture is providing the support. And now the tooling can take advantage of it, whether it's Visual Studio or Blend. All right, let's jump back over to Blend. And I'll show you a couple things that we haven't gotten to see yet. And the first is, how is this binding happening? Because we didn't do that. So let's go to our list box here on the left. I'm just going to go to Properties. And in here I have an item source property. And notice how this one has that gold border around it and a gold button off to the right. In Blend, that means binding. So you can look at the property list and see where binding is occurring pretty quickly. I'm going to get rid of this and show you guys how to add it yourselves. So I'm just going to reset that. So I now have no binding. And if we go and look, our data's gone. No binding. So a couple different ways to do this. The fastest way is if I go to data, and by the way, there's that gold border thingy again, because our view model is bound to the data context of our layout root. So that gold, remember the colors mean stuff. So I'm going to grab that collection, and I'm going to drop it onto my list box. You asked the question earlier, where did that data template come from? Blend just created it for me. It did a pretty awful job of it. I would never ship this, right? But what it does is it tries, when you do the drag and drop, it tries the best guess, and it's basically just finding all the properties that it can see and creating and adding them to the template. So that being said, I almost never do this for lists. So let's undo that. I do, however, do it for text boxes, because there's no data in the text box to display. So if we went just to finish showing, close that. I'll reset text, go back to data. This is our search owner name. So I can grab that and I can drop that on the text box. Okay, and that's fine, almost. So let me undo that. And now I'll show you what I'd really do in both cases. So we'll start with the text box, and then we'll go and do the same thing for the list. And that is to the right of all of these properties is a little button. See that little button there? Now you may think, as experienced Windows users, that a gray button means what? You're right, disabled. A gray button on a gray background with a gray border in a dark gray application. It's not disabled. It's just an interesting design choice. So all these buttons, every property has one of these. It's the advanced options. So when I click on that, and you've seen me use it a couple times already to reset, if I scroll down here, you'll notice I have the option for data binding. So when I click on that, it's going to open up the data binding dialog. And now I can drive through, and you'll notice this tab in the upper right-hand corner says Data Context. So the Data Context, that's the tab that we're on. So this is that representation of our view model, the same one we see in the Data tab. And this is the text box that we're doing, so I'm going to select Search Owner Name. And I'll show you, this is exactly why I do this instead of the drag drop. If I go down here to the bottom, they love to hide things in Blend. I call them Easter eggs. They're everywhere. You got to find these little Easter eggs because behind them are all kinds of goodies. So the goodies behind this one is the ability to change this binding to two-way binding. So this is the magic that allows that data binding to go in both directions that we mentioned way back when at the beginning of this presentation, like 3 hours ago. And two-way binding is the awesome sauce. So we want two-way binding because now if something happens in my program and changes that property in the view model, the UI is automatically notified. Conversely, if I go and type something into that text box, automatically updated in my view model. No passing values or parameters around. So the last bit that makes that possible is to change, and why this isn't the default, I have no idea, change the update source property to property changed. Otherwise, the default, and this is just silly, the default is lost focus. So you have to leave the control in order for the data to get pushed back into the view model. I never do that. That doesn't make any sense to me. Doing it this way, as soon as I type a letter in that text box, that property is updated in the view model. This is a much better way to do it. Should be the default.
And that tight coupling you're safe on in that you're handing back to a data class that has the get sets with validation at that level, correct?
Great point. Let me expound just a hair. So this is goes back to that whole idea of connected ignorance. And let me go ahead and finish this, this binding before I forget. Down here at the bottom somewhere, sometimes the projectors, I'm just going to hit enter and hope it works. Sometimes the projector makes it hard. By the way, if you're ever going to do this, you should really have two monitors. I use one for Visual Studio and one for Blend. But let's look at the XAML real quick now that we've created that binding. So I'll build. Oh, and actually, this will take 2 seconds. We're going to do the same thing on that list box to the item source. Data binding, real estate records. And notice how this time we only got the collection because it's matching types that it expects. You can still change that to all types if you need to see something else, which is beyond the conversation of today's scope. But when you get into doing converters and working with mismatch types and things like that, you'll have to do this. So, but matching types is, and I'll select all properties, and there they all are. But matching types is what we want. And again, actually in this case, I don't really need two-way binding because I'm not updating the list in my UI. If I was, though, like a data grid or something like that, two-way binding is, again, awesome sauce. So I'm going to leave it. The default is fine. I don't need to change that. But the reason I do lists this way, the reason I do text box this way is to get the two-way binding. The reason I do list this way is so that it won't create that stupid data template that I don't want. That's simple. So since I've been messing around with it, I do need to go back and add the data template in. And let's see, the fastest way to do that edit template, items template. Y'all are going to remember this, right? Apply resource, real estate master template, and let's build. It should have. Oh, I didn't finish the binding. I'm sorry. There we go. Okay, and we got our design time data back. So a long way around to get there, but very important points. Use the tooling correctly. Now, let's look at that XAML real quick before we run out of time. Let's build. Always build before you switch. Let's go back to Visual Studio. Yes to all is always the answer. And let's take a quick look. I don't want the design thing. I want you to go away. Well, I don't want you to go away. Okay, good. And what we're going to do is we're going to find that text block, which was in here, text box rather. There it is. We'll do Control-KD to reformat. And here's our binding. So this is, notice how there's the two-way, there's the update source trigger. This is the XAML that Blend wrote for us. That's fantastic. Now, the reason this is safe, binding property name. There is no reference here to the class. This doesn't know that search owner name belongs to a particular class. What it's saying is, please, sir, try and find this for me. And if it doesn't, it just does nothing. Just fails gracefully. Which is really nice until you edit this in XAML by hand. If you're using Visual Studio, if you're anywhere near the caliber of developer that I am, that's what you'll do. That's a joke. You can laugh. It's okay. A typo, a simple typo. There's no error here. You will never see this in a compilation report, and the application won't bomb, and you'll pull your hair out trying to figure out why, oh, why doesn't my binding work? This binding doesn't work, Blend sucks. No, I'm sorry, that's not it, okay? It's a simple, I mean, it's a simple error that we've all done. The problem is it fails a little too gracefully. So if you're doing this in Visual Studio, this becomes a problem. If you're doing it in Blend, this is never a problem. Because using the binding tools in Blend, it will never mistype a property name. Make sense? Okay. Could save you hours of work, by the way. All for a little letter. All right, let's build this real quick. Let's jump back to our manifesto. And we have one more principle, the testability principle. So here's my take on unit testing. I think it's really cool. I also think that I'm terrible at it. I don't put the effort or the discipline into it that I know that I should. So if you're in that middle ground somewhere and you believe in unit testing, but maybe you don't do it, it becomes really easy to kind of skip over the unit testing pieces. That's a bad idea. For one thing, you might have other people on your team who are into unit testing. You might have QA people who actually write tests. And someday you may decide yourself, yes, this is important enough that I'm going to invest my time in it. You don't want your architecture preventing unit testing. That's all it says. It doesn't say you have to unit test everything. Just make sure that when you put your architecture together, that it can support unit testing. This is by and far the easiest of the principles to accomplish, because we have already done almost everything we need to do for this to happen. As a matter of fact, we've already done everything we need to do to support unit testing. We just need to add one little thing to make it physically possible. If we go back to our source control. Oh, I didn't have time to talk about commanding. Let me do this real quick, and then I'll take 2 minutes. I'm going to jump ahead to testing, and then I'll talk about commanding real quick. Very important, but really quick. Okay, so we've gone back now. Let's go to Visual Studio. We'll reload. We'll build. And we're going to go look at our view model. Because we already created the data service, because we already mocked out our data for design time support, and we have this concept of a service and all that, all we need to do is add the ability to inject another data service. So our data service then, we set it and then run that start BAP, which bypasses the going out and figuring out whether or not I'm in design time. So I pass it the data service I want to use, and by injecting it, my testing framework, when it instantiates this, can create its own view model for testing and pass it in. Or it can just use the mock view model that we already created. It's already got data in it. Make sense? That right there is all it takes because of the other work, the framework, the groundwork that we already laid. That's all it takes to support unit testing of this view model. OK, so with my last couple of minutes, I do want to go, like I said, I skipped a step. I do want to show you commanding. It goes back to something I said earlier, which was this relationship, this two-way relationship between the view and the view model. The actions that are requested from our UI actually go to the view model to happen, to work. So we don't go into the code behind to write our code. We go back to the view model. And we pass those things around through binding to using a mechanism called commanding. So if we look at the project, we'll see that we've added in our helpers this concept of a relay command, which, and the link is provided here for you. I actually got right off the MSDN website. Works great. And what this lets me do, because commanding itself, we can do a whole talk on commanding. Obviously, we're not going to go in that much detail. But you can write your own commanding classes, which is kind of the traditional, if you can call technology that's only 5 years old traditional. This is a traditional way to do it. That's too much work for me. I'm very lazy. I don't like to do that much work. Relay command lets me delegate. It's another name for, you'll see some implementations call it a delegate command. Lets me delegate the two things that a command does to one class. So I never have to write another commanding class again. I'll just instantiate this one. The two things that a command does is it has an action. In other words, what does my command actually do when it's executed? And then it has a can execute property. So I can either, can I execute or can't I? And if I can't execute and I'm executed, what do I do? It's the only two things I have to provide. So this relay command, we won't go through all the specifics, but you basically pass in an action delegate for the execution and a predicate delegate for the can execute. And the rest of the details we don't have to go into. Let's look at how we use this in the view model itself. And here is a search by name command. Search by name command, again, is an I command, and we're instantiating that relay command class. And we're saying, when you are told to execute, run this load real estate collection by name method, which is actually inside this view model. So I have access to properties and methods within my view model. If I pass this off to another commanding class, I'd have to pass the view model itself or the data. I don't have to do that doing it this way. So if we go and look at that. Oh, and then before I move on, just our predicate says, allow this to happen if and only if there's an actual search property entered. So if we go back, now we can look at load real estate collection by name, which we saw earlier. And notice how it is also testing. If not, it's just not going to do anything if I don't have a search parameter. But I'm using search owner name, which was the very first property that we saw. It's just a binding property in our view model. So the view is bound in this property, that text box up at the top, to the view model. I type something in. That gets evaluated as a can execute because it's no longer null, which will enable the button that my command is tied to automatically. And when it runs, it just uses that property. So I don't even have to pass parameters around because they're already here. And then it goes and hits my service and gets the data. So let's look real quick at Blend. Say, oop, did I build that? Let me make sure. Blend gets finicky if you don't build when you update the source control. Okay, so here is that text box, and right next to it is a search button. And notice how, even in the designer, my search button is disabled. That's because that button is bound to the command. And it's not going to show it to you there, so let's pull up the XAML. Oops, sorry about that. We'll do split view on the XAML real quick, and because I have the button selected, it selects it down here. And there is the binding to the command. And it's binding to that search by name command that we defined in the view model. And automatically, that is enabled comes along for the ride. So notice that in my button, there is no is enabled property because it's automagic with the command. So by providing can execute, I get that feature out of the box. And again, at design time. So let's do one thing we haven't done yet, which is run our application. I'll cross my fingers. So it'll take it just a second to start up because I am mistakenly loading the entire stinking database. Yeah, more realistic, right? Okay, it doesn't look like much, but because I've got a bunch of bad data at the beginning, but if I scroll down here, there's my live data. So earlier we saw test data. Here, using that service concept, because we're at runtime, we're now getting live data. My button is disabled because it's bound to a command, and it knows that the search property that text box is bound to is currently empty. So let's type something in there. And you'll notice, because I'm hopefully in this version doing the two-way binding and the property change update we talked about, that as soon as I type, my button should become enabled. So let's look for, yep. So all I had to do was type something in that box, and then miracle of two-way binding with property update changed automatically then reports to the command that it changed, and the is enabled got picked up automatically. Automatic, automatic, automatic. So let's do Jones and search. And there's our search. So that went through, when I hit the button, it went through the command, bound to the view model, went into the view model, and executed the code against our service. Any questions? Yes?
Can you go to the XAML binding again? The
Sure.
source code. Can we possibly do a name space, for example? Right now, it's just a simple binding with a particular property. So you have something like a two-way search. Yes, search name by command, search owner name, for example. All these bindings, can we put a namespace for that variable?
No. What it's going to do is it's going to look in its data context for that property. Okay. Now, what you could do instead of a namespace is you could specifically reference a different data context or a different element for that binding.
Okay.
Okay. So it's not a namespace, but there are ways around there. If you have multiple data objects within your, now if it's within the view model, which is the way it should be, if you're following my principles, it will be, then it's just going to be inside your view model. But if you do have multiple models, yes, you can, or multiple instances within the XAML, yes, you can do that.
Yeah, we may have multiple models.
Yeah, but if you're following these principles, those models will be wrapped up in your view model. Okay. So let's say the model was, there's a search parameters model. or a person model, owner's model, what have you, within your view model, and it was named owner, and it has a property called search, okay, then it would be owner dot within the binding. Okay, so you can bind two child properties.
Okay, that's good.
Anybody else? If not, then thank you very much. I hope you had a good time.
Tech Connection Live. Brought to you by Component One Ultimate. Download your free trial at componentone.com/ultimate. It's easy to build everything, everywhere, with the right tools and resources. Component One Ultimate delivers just that. Whether you're a Windows, web, or XAML developer, the Component One Ultimate Collection enables you to create any type of application. WinForms, WPF, Silverlight, ASP.NET Web Forms, MVC, Metro, Windows Phone, iPhone, Compact Framework, and even ActiveX. This comprehensive package not only delivers hundreds of .NET controls, plus powerful OLAP data analysis controls, it even includes SharePoint web parts, documentation and screen capturing tools, light switch extensions, and tools for ADO.NET Entity Framework and RIA services. Plus, ESRI mapping controls, the most comprehensive controls available for GIS application development. Component One Ultimate, the ultimate collection of tools for software developers. Go to componentone.com to download your free trial of Component One Ultimate.